We now have our next conversation with my friend right here, Thomas Jonas, the CEO of Nature's Fynd. Please give him a round of applause.
Hi.
Thomas, you do some interesting work. Can you talk about it? I'm going to leave it open like that.
I do interesting. Who does interesting work here? That's what I was hoping. So I'm definitely not the only one.
Let's be a little bit more intentional here. So I want to thank Nature's Fynd for joining us. They've given us some wonderful products. I hope everyone has enjoyed them. But I need you to explain fermentation to folks because not everyone knows what it is.
Well, let me just give a little bit of a side.
I left this open for you.
Okay, let me grab. So we have some products here, by the way, that we're serving right now, which are, they're not meatballs. They are not vegetable balls either. They're made with an extremophile fungi that we discovered a few hundred miles north of here in the volcanic springs of Yellowstone. Thank you. So
just one interruption. This was NASA-supported research, right?
Yeah. So I'm completely not qualified to do what I'm doing. let's be honest.
No one here is.
So we started our company really started as NASA research on the origin of life, on extreme forms of life, and this took us. And really, what NASA was trying to do is figure out if they were going to send a probe to a moon of Saturn. How should they look for life? What do you look for on a moon of Saturn? I mean, I don't even, in the methane lake of Titan, in the geyser of Enceladus, what do you look for? We don't know. We know life on this planet. We have, the data is just one life form. We have no clue. So we went to a very different place. And that different place is, as I just mentioned, a few hundred miles from here. You can continue the ridge up north that we have here, and you will get to Yellowstone National Park. And Yellowstone National Park is actually the biggest supervolcano in the world. And under Yellowstone, you have a gigantic lava chamber, which is just, there's nothing like that in the world, really. And it creates a very particular geological environment. And there are these springs, this water that has a pH, an acidity level equivalent to a car battery. But life finds a way. Mm-hmm. And across thousands and thousands and thousands of years, life adapted to this incredibly hostile environment in the forms of microbes. And we discovered these microbes that some of you just ate. And if you had our yogurt this morning, you just ate them as well. These microbes are amazing. And really one of the things that they do is, because they're in this very unique environment, they have to be incredibly efficient. And being efficient means doing more with less, is what our generation call really is. This is what we have been talking about today, right? How do we learn to do more with less? And here what we're really doing is we're taking a page out of nature's playbook. Nature's over there, where there is very little resources, figured out how to do more with less. And we developed a technology to grow Phi. So we named it Phi. When you discover it, you get to name it. So we name it Phi. And that stands for Fusarium from Yellowstone, hence the Y. And we call the company Nature's Fynd, because we found it in nature. We didn't make it in the lab, we found it in nature, and the Y is just a reference for Yellowstone. And so that's what we do, to answer your question, and we do that through fermentation. So we developed a way to cultivate this microorganism. Now, it's fermentation, and we think it matters. So food matters, right? I think we're all going to agree, right? We're all going to agree here. But I think it matters even more than we think. I think if we just look at a breakfast table where there is sugar, tea, coffee, you have 500 years of colonialism, you have slavery on that. All of that is in that food choice. Just think about it for a moment. It's really incredible. Now, what do we want to do? How do we want to steer the world today and make choices and build up technologies that take us through a different direction? And that is what we're trying to do through that fermentation. So now, why is that interesting? It's interesting because, guess what? We can do it. We currently do it at the corner of Pershing and Halsted in Chicago today, by the White Sox Stadium. And that's a beautiful thing. We can create that protein using a fraction of the water. So 99% less water, 99% less land, a fraction of the greenhouse gas. And yes, it tastes good. So again, it's there. If you want to try, you can be the judges. You don't have to take my word for it. So it's not science fiction.
Right.
It's science.
Right.
But food is science. Food is science, right? Food is the primary technology of our species, right? We invented fire. We invented to cook food. We invented agriculture to get our food. So food science, it's the same thing. It's fundamentally the same thing. So that is just what we do at Nature's Find.
I want to talk a little bit about, we hear about alternative proteins and cultured meat all the time. We hear less about fermentation, a little bit more than, last year. I think it's growing every year. Do you think that there is enough, can you scale this, the idea of plant-based proteins and especially fermentation for, battling the climate crisis?
So the answer is yes. And that's so what we talked about fonio earlier, and it was fantastic to hear about fonio and learn about fonio. I thought that was so exciting. What were we talking about? We were talking about biodiversity. Now, about 70% of the food we all eat is coming from less than 10 crops. Less than 10 crops. There is millions of species. We're using less than 10 crops. And by the way, they're not necessarily the best one. They are the one we knew are there. We basically domesticated them about 10, 11,000 years ago, and it's what we've been doing ever since. And it's true for the animals that we're eating as well. So there are other things. There is fonio. There are a lot of other things, and microbes were something we didn't see. So our organism is probably older than a cow, but it's much easier to see a cow 11,000 years ago than it is now. So now that it is now to see our microorganisms, to see fire. So now that we know fire is there and we can cultivate it very efficiently, as I said, this is actually what enables the scalability. So think about it for a minute. We have about 20% of greenhouse gas that comes from agriculture, as it is done today. So I live in Chicago. When I flew out of Chicago for about an hour, in whatever direction I'm going to, I have to fly over corn. I have to fly over soy. And by the way, about 90% of that is just to feed the animals. Right? 90% of that is to feed the animals.
The other 10% is for cars.
That's right. That is
corn,
right.
Yeah.
There is almost nothing in there that's actually for food. And yet, it's taking about 40 to 50% of the water in the US. So how scalable is that really? We know the answer. The answer is that's not scalable. The current food system is not scalable. We know that. It's not scalable when we get to 10 billion,
Sure.
and it's even less scalable in the context of climate change, which I don't know if you heard about it. It's actually real.
We've heard, yeah.
Yeah. So yes, I think we have to understand that the current, and I'm kind of preaching to the choir here, but the current food system is not scalable.
Yeah.
So what do? What do we do?
Tell me.
That's where we can harvest nature's playbook and really look at how nature has been optimizing some of its ecosystem, and the way these microbes are growing is really a testament to that. So we are able to grow phi in Chicago using just water, some sugar, and some salts, and that's all we need. And we can grow this miracle of nature. That's it, just with that.
Sure. So let's talk about the nutrient density of building this product.
Yeah, so the 5 bites that we're serving here, with one portion you have about 15 gram protein, you have about 5 gram fiber. The nutritional density is really incredible. I mean, you have fiber and you have protein, which is kind of unusual. So the yogurt that we're serving this morning, for instance, it's a yogurt. We have about 6 gram fiber in it. It's a yogurt. You're not supposed to have fiber in yogurt, but you actually can. So the nutritional density of these products are absolutely phenomenal. So how the big challenge for the sector is, how do you communicate about it? How do you bring something new to people? Mm-hmm. And I think that's always a challenge in food. I don't think it is as much a challenge as people sometimes believe. I think we tend to think about food as weird for actually a short amount of time. Sushi was weird until it wasn't weird. Right? Fonio was weird until we all heard about it, and now we all want it. And I think that's that moment of weirdness is not, it doesn't last. In case you're not sure, I'm French. In case you didn't pick up, in case you thought this was Illinois accent, no, I'm French. There was this guy called Louis XIV, and at the time that coffee was brought to him, he tasted it and he said, "This is never going to work. I'm going to stick with sage water." Right, so, and you know, I don't know if you guys ever tried sage water. Nobody's eating sage water anymore, drinking sage water for breakfast anymore. So this habit actually changed very fast. I'm absolutely convinced that within the next few decades, we'll have about 10, 15, 20% of our protein that will come from fermented sources. Just because it makes so much more sense to cultivate these microbes using a fraction of the resources that it is to do the sort of farming that we're doing for animal protein today.
Well, and you know, a lot of people are talking about cultivated meat, cultured meat. This fermentation process doesn't have the same sort of disadvantages that does.
So first of all, science is cool, right? So people are like, science is my food. I don't know that I want that. And I understand that. But again, cooking is science. Your kitchen looks like a chemistry lab, right? Yeah. That's what you're doing. You're putting things under heat. You're adding salts. That's chemistry that you're doing. So, but on fermentation, there are various types of fermentation. So there is what's called biomass fermentation, which is what we're doing, where you're just growing that biomass. Then there is precision fermentation. So it's a little bit, you have the microbe make something. It's a little bit like the microbe is a cow, and you're milking the cow, you get the milk, right? So that's precision fermentation. So people do that to do, for instance, some milk protein. Or other protein. I mean, you can do a range of things. You can really use the microbe like a miniature new factory, but at a level of efficiency that is incredibly exciting. Going small enables you to get the same gains in efficiency that you've gotten from getting the big room that was one computer transistor to what you have in your iPhone now, which is this tiny little thing. So by getting small, you're getting tons of efficiency.
Yeah.
When it comes to cultivated meat, I think that's not going to happen overnight.
Right.
There is
taking
still
a very long time.
That's very complicated. And there is a reason, I mean, think about it. You are all have muscle tissue, just like the cow, but you also have kidneys, you have a blood system, you have lungs. All of these are support system to your muscle tissue, or to all the cells in your body. You're not going to last a long time without kidneys. You're not going to last a long time without lungs, without heart. And reproducing all of that in a fermentation system is technologically very complicated. So that's not going to happen overnight. It's possible, but it's going to be very difficult to scale. Biomass fermentation, on the other hand, it's something, as I say, we're already scaling it.
Yeah.
And the really exciting thing is, not at a very big scale, actually. We can be at parity with chicken. Right? We can be at parity with chicken. Those are not at all crazy number. That's why it's going to happen. It makes sense. It can be cost competitive. Yeah. And hopefully, again, feel free to try the product there. Yeah. It's something that you would want to eat.
Absolutely. You know, you've brought up efficiency a bunch of times. How do you tell this story through data? And how do you convince, retailers to take this on?
So we launched our yogurt at Whole Foods last year, And at the end of the year, we were the fastest growing yogurt in the alternative protein category at Whole Foods. So we're pretty excited about that. Because it's very creamy. It's a very creamy yogurt.
Yeah,
so
it's delicious, actually.
Thank you. But one of the things we learned talking to consumer is that they don't quite care about the data. I'm going to be a little, retailers do care.
I care about the data.
But here is what we see. And again, at this point, we've done probably about 1 million portion, and we've done tens of thousands of sampling events. And what we see is something that I find is absolutely mind-blowing, actually. We have an apparatus in our body with our nose and our mouth that is an incredible scanner, and that evolved through evolution to make you detect what's good for you and what's bad for you. And you know that in a split second. So if you eat something, you're going to like it or not like it, and you're going to know in about a few tenths of a second. And then I cannot change your mind. Data is not going to change your mind if you don't like it. Data is going to bring you to the point where you might try it.
Sure.
But data is not going to do anything if you don't like it. I can tell you this is the best possible thing. You should absolutely take that. And if you don't like it, you're going to say, and you're going to walk away and you're never going to buy it again.
Yeah, it's taste over everything.
Taste appeal remains something very, very important. Now, of course, I think we're getting at a moment in time where people want to be, once you've passed that, you need to convince people that it's good for them.
Sure.
And that is the second thing, and that's where the data come in. Like, what's the protein content? So we're very high in protein. We have a complete protein. So complete protein means there's all this little Lego brick that are the essential amino acid, the amino acid that help everybody build and support a strong body. It's actually pretty rare. In plant-based, plants typically do not have all of the essential amino acid. It's a little bit like you're buying a car with only 3 wheels. So it's good, but it's not great. So you need to make sure you supplement your protein. This is a complete protein, just like animal protein. So when people learn that, then they are like, that's interesting.
Yeah.
But again, if you don't pass that taste test, you have nothing. Nothing.
Yeah, taste is everything.
Taste remains everything.
Thomas, I wonder if there are particular regions of the world where you think this process could work really well and help folks and help create, a healthier food system, a little bit better food system, a more affordable food system?
Well, yes, I think there is this place called Planet Earth, which is, we've actually grew it in space as well. So my goal is that when Elon Musk gets to Mars, we'll be there with pushing our stuff already. But look, there are places in this world, and it's actually not the United States, where water is a very, very, very real issue.
Yeah.
Much more than it is here. And by the way, it is an issue here. I was in the Gulf just a few months ago. It's actually absolutely fascinating. They were completely depending from the outside for their protein. So they decided to start building these gigantic farms for poultry and for beef, and cows, dairy. So they really built the biggest farm in the world. And then they realized one thing, which I think it's a big secret, and I'm going to share a big secret with you. Not a lot of people know that. But the cow, the chicken, you, me, we do not make new protein. The cow doesn't make new protein. The cow breaks down the protein like little bricks of Lego and reassemble that in other protein. Right? What does that mean? That means that the Saudis had to start importing enormous amount of feed because that's where the protein was, a very dilute protein in the feed. And then they had to feed the cow and the chicken and all that. So they were not protein independent. If you want to be protein independent, there is only 2 ways to do this. You have to use plants or microbe. good luck doing plants in the desert, in the Saudi desert. That's not going to work. So the only thing that you have left is fermentation. It is literally the only thing you can do. You have to cultivate microbes. Otherwise, it's not going to work.
How receptive are, the Emirates, the Saudis, to this kind of thing?
So it's interesting because it's a culture where there is a strong premium on meat. So meat is the macho thing that you should be eating.
Yeah.
And it's not just the macho thing. It corresponds to a certain standard, and meat is value.
Yeah.
Right. And they are really kind of stuck and in that world. They totally understand that that's not going to work for them. Like they cannot really develop that meat system that they're craving for, and they want to be independent. And just a quick note on that: a few years ago, the Saudi decided to blockade Qatar, and the Qatari literally had to push cows into helicopters, get cows with their feet to come through Qatar and be delivered that way. There is no independence in food in that region.
Yeah, absolutely.
If things go wrong, they're all going to starve.
Yeah.
And by the way, during COVID, they had to literally make phone calls to the very big producing countries to say, please send us food. Of course, they can pay. So all of their question right now is how do they evolve their petrodollars into food? How are they going to build this industry that are going to make them independent going forwards?
Yeah. Thank you, Thomas. Great explanation, great conversation. What's your call to action?
Just earlier someone asked me, what am I doing what I'm doing? And the answer is because I can.
Yeah.
And so what I would like you to think about is what can you do? And trust me, if a bold French middle-aged guy can do something, there's a lot more that you can do. And as I said, I have zero qualification to do what I'm doing, but just do something.
Yeah, just do. Thank you,
that would be my
Thomas.
call. Thank you.
Thank you. Big round of applause for Thomas and Nature's Find.